Welcome back, guys. Yeah, so let's see where we were yesterday and let's get started. Yesterday we were uh, almost good with the actual directory parsing. We managed to fix the recursion issue, but I mean, like, we didn't actually find what was wrong with our recursion, but I was pretty sure that it's just my actual index that is not being passed properly. So what I did is that I just managed to move that variable into a global variable, and I tried it and it was working perfectly. But after 40 directories, we somehow reached some other issue, but then that's not related to the actual recursion that we were debugging for past 2 days. And so at least we have managed to fix the recursion issue. At least we managed to find a way around it and it's just working fine. So yeah, let's continue with that today and maybe figure out what happens after that, because after the 40 something directory we were not able to parse further. So let's try to figure out what happens there. But overall, we are still working on our own kernel. We managed to finish our MMU unit, scheduler, and yeah, we're currently working on the VFS layer, and part of it was the block layer, which is done, and we are currently working on the front end, which is the X4 file system. So it's all going well. Let's see. Let's just get into it. So, as I said yesterday when we tried to run it, let's just run it once just to see what it does. And just run it. It's currently able to parse up to, I guess, 50 directories, and after that we are somehow reaching some issue, but that's not related to it, and we are able to parse up to 50 directories, and we are also able to store those 50 directories into our directory struct. So we are pretty sure, at least I am pretty sure, my fix is working, and the fix is pretty simple. I just moved the current length out of the recursion, so it's a global variable and it can just be always be used, and we only have only one place where we actually increment it, and there's no multiple threads here, so it should just work fine. But other than that, this fix is fine, but as I just mentioned, that it is not thread safe. So somehow we need to make sure it is thread safe, because we might be calling this function from multiple user processes. So we need to make it thread safe too. So what I was thinking is that instead of just calling it as current length here, let's just pass as a reference instead of value. That is that should also work just fine. So let's do that. It's going to be event 64 pointer. We want to allocate that, and it's going to be total directories. It's going to be C, and it's going to be kmalloc. So let's use kmalloc, and we just want a size of uint 64, and that should be enough. And let's also just what size of, sometimes I just, and let's also cast it as uint 64, so we would not get any compiler errors. And let's remove the return type. We are not gonna get anything out of it, so let's change the signature later. But it's going to take one pointer, which is just the C, and it's going to be pointed to event 64. So within the function, we just have to change two things. Let's rename it to void, and we don't need this anymore. Let's remove that, and we're not gonna take one thing, which is a pointer, and it's going to be just event 64, and it's going to be current length. Okay, so now we have the current length. Okay, we have the current length that we need to pass, and we'll have to dereference stuff. So let's just use this. I'll also just use this. Hopefully this will work. But just to be sure, maybe we could do one thing, which is let's just take the current output out of it. So it's going to be cout, and it's just current length. We can just use cout here then, and print cout, and finally we could just use cout plus 1. Okay, I believe this should work because we just took the value out of it and used that as the index, and further we dereference it and update it with the cout plus 1. So it should work just fine. And finally we pass the same pointer again, which is just current length. We don't dereference it, we just pass it directly. And void cannot have a return type, so it's just simple. Okay, I believe it's good. Let's kill it and let's start it again. Let's see what happens. Okay, we have some errors. Okay, we have a return type. Let's just remove that. Let's remove that and let's dereference it here, so we will get the same log. And that should be good. Let's kill it, and let's run it again, and that should be it. And we are able to get the same output, as in, because we currently have up to 50 directories. What we can do is just to confirm if it is working fine, let's change this to 12, and let's also go back and change it here, which should be, yeah. And if we do that, and let's kill it and run it, and if we run it, it's working, because there's only around how many directories we have? 30 directories, and the 30 directories are initialized and printed properly in our output. So that's exactly was the issue that we were trying to debug for past 2 days. That is, our recursion was not able to pass the values, and somehow I was not able to get that value as a value. I was not able to pass it properly between those recursions, but it's fine. We don't care. We can just always use, I mean, like initially I just tested it out with global variable just to confirm that it's my actual length that is being fucked up and it's not something else. And then once we know that it is working, we can just convert that into a reference, so it can also be, it will be thread safe, so no matter who calls it, they can just allocate a new length and pass it down. It should be just fine. So that's all good. So let's just get started with the next thing. That is, the moment we increment these two values, that is the number of directories that we can parse within a level, we seem to reach some sort of error, which is, as you can see here, we were able to parse up to 30 and then we are printing everything, so it all worked fine. The moment we change it to 24, that means there's a lot more directories to parse. The moment we do that and the moment we run it, we are running into this fucking issue, which is just completely random because probably something else is causing the issue. But we are reaching up to here and then we are getting some sort of crash. Okay, so that's fine. So let's just see what exactly is this error. So what we can do is initially let's create a separate one and let's kill our camo logs just to be sure that we are dealing with the proper log. Is there we can't find the proper log file name sometimes. So let's run it again, kill it, and now if we open the camo log, we have one log file and maybe it's not the sector. I'm not sure. So let's do one more thing. Let's enable every log, which would actually increase the total time, but it's fine. We need to know what the fuck is going wrong. So let's do that. Let's kill, remove all camo. Okay. And then let's just run it again. Now it will be extremely slow because we have lots of logs to maintain because it's just going one at a time and it has to print thousands of entries and we are stuck somewhere. What? Okay, that's probably something else. We don't want to deal with that now. Just by including all my logs, I'm getting, let's just remove the logs, build it again. The fuck is happening? Okay, I just remove this log message. This is just to get every debug log. What the fuck? Let's just build it again. Is there any error? If there isn't any error, how come? Okay, file template seems to be okay. I fucked up. I just need to disable this. Hi, hello. So let's now if you run it, it's working fine. So let's remove that and let's enable all logs and let's also remove this camo that we had previously. Now let's just build it again just to see why. Okay, for some fucking reason, if I enable my logs, also just every log, it's fucking with my setup. Or maybe it's just taking time. I don't know. Let's wait then. Let's wait for two. Okay, it's just taking time because of the logs it has to process. It's just slow. It's nothing much. So it's just slow. So it's not stuck. It's just slow. I believe so. Yeah, it is just slow. It's just going one at a time. Yes, I'm pretty sure because it's still running. I don't know what is this though. What exactly are we trying to do here? I guess we're still in GDT. That's like the initial phase of my entire kernel. So initially, when we enable when we jump from our initial start to kernel, we have an initial parser that goes through the entire GDT to get the current RAM size and the current offsets and stuff like that. But this does not seem valid. Somehow something else is going on. But let's just wait for a few more minutes. If it doesn't go well, let's just forget about getting the logs and we'll debug it with just print messages. Or maybe we could use scoped logs because here I used to take just virtual logs. Maybe we can just look for any MMU logs because probably what's happening is that we are getting some page fault. So I just need the page fault address so we can look for specific ones. Okay, we can do that. Where is my browser? It's here. Okay, so let's see. I need what do I need? I need to get only what is it? MMU logs from Chemo D command. Okay, we just put type D and MMU. That's it. Okay, we can do that. Then let's just stop this. Enable this. Okay, let's keep this too because it will be useful. Let's just do the and that should be good enough. So now let's kill it and let's also do this because as you can see it's taking a lot of time because there's just so much logs and it worked. So let's kill it. Now if we go into our camo, it has nothing. That's odd. Let's try. Is it the only camo log? Yes. Let's try something like trace MMU. Would that work? I'm not sure. Let's try. Maybe it will, maybe it won't. We'll now know. Do I need to watch operations? Yeah, probably we'll need to watch other streams because it's incremental. I'm just keep on working on top of what I did on my previous stream. So yes, but maybe if you know enough stuff about kernels, probably you can keep up because currently I'm just trying to debug a probable MMU faults. So I'm just looking for camo logs. Okay, fuck it. Let's kill it. Now run it again. Maybe it will work, maybe it won't, we'll never know. Let's go into our log, and it's still empty. It's not working. It's working. I need all sort of page faults. Faults with the far code. I guess I'm not sure if you guys watched my previous streams, you would know what is far. We could just grep for far if in case we were able to run the entire Kernel logs. But I don't know, let's see. We just need the proper trace command to get all what the fuck is int? I mean is oh fuck it. I typed it's um and if we just get for far, we should actually get the actual exact address that faulted, and the far code would give you which level it faulted, like 7 means I guess L2, something like that, and we can just search for the code and get it. Yeah, this is exactly how the error would look like. We could just grep for far and we'd get the actual results. So let's print for int. I don't know if it will work, we'll try. I don't know what int stands for. How is that related to MMU? We will never know. Well, let's just do one more thing. Let's just kill everything first of all, and then redo. And then if we come back and just type camo, okay, now we have the errors. As you can see, when we try to go from EL1 to EL1, probably we were already in EL1. Yeah, we are in EL1. We have an exception. Let's grab for far then. It should be grab far. Okay, let's also just print AI, and let's put, we need 5 characters, 5 lines before and after that. So now we have the final, we have the first and the last. Holy fucking moly. We can't go to top directly. Whatever, let's do this. Put it temp tests. Let's open temp tests. And if we go to the top, this is the first message, the first var, and when we try to access this address, we got fucked. And it's definitely my heap, I'm pretty sure, because my heap starts from C something, so it's definitely my heap address. And what's the error code? It's 6. That means probably L1. No, L2 probably. I think we have a fault in L2. ahead and let's copy this and let's fucking paste this, convert the code, explain the error code and the table level. So I believe it's level 2 because I don't know, 6 means we can just search for it. That should also work. You can search for this. So it's okay, whatever. It's still fucking debugging. Oh, shit. I think back when I was actually debugging MMU a lot, I had this reference page where we could just paste the error code and we would actually able to see what sort of error it is. It's an ARM developer manual, but right now because I haven't been debugging MMU for a long time, I don't remember exactly what that name is. Maybe we could just try as developer manual about EL exception codes. It's possible. Maybe this is the one. I'm not sure. Let's just see. SSS for 06. There's no fucking 06. Okay, I need to convert that into hex to decimal. I'll just put decimal and we would still see the binary, so it's fine. Hex to decimal and I'll just put 06 and my code should be this. If I just search for 110 translation false level 2 and we know that there are more zeros in front, so it's definitely this translation false level 2. But we also have to make sure that if there is extra bit set, that means it's permission fault, it could be address fault, but I believe it's translation fault. Let's double check. It's fucking meets it got throttled or something. Let's just say copy it. Let's copy it and just put paste. What is the table level? Yes. Hi. I am not sure why it's taking so much time today, but at least from what we can tell, it's either we can just say either just debug the entire thing. Let's take this. We take this and here, and we'll get this. And as per the manual, we take 5 to 0 and 5 to 0 means it's just 0001, and 0001 means translation fault level 2. Yes, 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 I do remember. How is it going? Okay, so we do have the translation fault in level 2. Why would we get a translation fault in level 2? That means I need another table? No? Oh, it's fucking annoying. Explain the table fault level. Okay, it's data about taken. Table fault in level 1. That's not possible. Must be level 2. It's fucking with me. There's no way I got a level 1 fault because level 1 means around 512 GB per entry, so for sure it's not level 1 entry. It's either level 2 because level 2 has 1 GB and level 3 has 2 MB. So it's definitely level 3. And so now it's definitely level 2 page faults. And I was trying to access this particular memory. So, and my ELR was this. I mean, this is the next address to go for, I believe. So, if that's the case, then I need to debug my L2 entries. Let's see. Let's go to our MMU. And it's somewhere here, definitely. It didn't get any other errors, right? We only got indexing within block and then it just got fucked. And I store up to 20 L2 entries. Okay, I'm not fucking... I don't know. Looks like we are allocating up to 512 size to... Maybe we can change this to 20 and total. What's the total actually? total is 20. Maybe this is the one that needs updating. And let's see. Wait. Okay, let's just put 4096. Let's start it again. So, okay, so that's not the issue. So just remove that. Because yesterday we fixed one thing here, which is to, where's the fix? Which is to add 4096 here. Maybe then, maybe it is 4096. Because I am using this address here too. So this, that. Okay, fine. That's not related to this bug, but here I believe somehow we're not able to write to L2. Did I manage to actually allocate that much space? So we are past this entire thing, but that's not possible. If that was the case, I should have reached this case too. Wait, let's do one thing. Let's check these two addresses. What's that? Let's build it. And let's say, let's break. No, let's disassemble this. We don't need the FFFs because we haven't yet switched that. So let's change that to 1, 2, 3, 4. And what is this? It's inode num to inode. Okay, what is this? Let's disassemble this. And this not like that. We could just 4 and 3, 4. What the fuck? Why is that address not possible? What's wrong with that? Oh, it got killed. Now let's start this and then start this. Oh, fucking no. 1, 2, 3, 4. 1, 2, 3, 4. And it's not a function, so let's try 10i. And it's undefined. Possibly what we are doing is that because this address looks exactly like an table address, because as you can see here, my tables start from, or my tables use the address around 8000. I guess also 3000. I'm not sure. Let's see. Yes, but it's extra space, so maybe it's not the case. Let's see if there's any 3000 at all. I think it is there. And it says it's L2 base. But those were old code. And what's this base? 1000. Maybe that's not the case. Okay, that is definitely not the case. But we are pretty sure the address that faulted is this, which is inside our heap. So somewhere down the line, when we try to actually access something from our heap, we are getting an issue. Okay. How do we debug that? I usually just convert this into proper address. To actually fix it, I either have to change the address that is already paged, or I'll have to figure out which table is missing the entry and add the entry. There's only two options. And in this case, because this is a dynamic thing, I don't think we can add anything. Because by default, whenever I actually implement, initialize a table for this dynamic entries, it's automatically everything is paged. What is this? That's something within. It's possible that it is disassembled. And just zeros here. And what is the function? I think that is the I know to know. Okay, somewhere down the line when we call I know to num, we are trying to allocate stuff and then it's getting fucked. Okay, how do we fix this? We have to understand the exact table entry. So we need to convert this far into proper table entry. Explain exactly which table entry is faulted. No, which table entry is accessed. No, which part of this address, which part of this address? Because for every table, the key is different parts of this address. So we just need to find which part of this. We can ask this to Claude because that will have better understanding of this. And let's just keep this. We have an page faults. Which table and which indexes fail? Explain. It's possibly L3. Well, if it was just the table total length, we can increment it. But if it's some other issue, then we'll have to debug it further. So let's see. It must be, it's definitely in this function, that I'm pretty sure. Because only here we allocate things dynamically, because every time we create separate L3 tables, we make L3 tables with set entries and stuff like that. We do a lot here. So yeah, let's just see. Hopefully it's not a big issue or a big error, and it's just something real. Yes, as I said, the actual VA is that, and we have to figure out why this VA, this is the virtual address that's being attempted, and it does not have a table entry. That's the issue. So now we have to figure out why our table does not have that entry. Either the table itself is missing, or what could have been. I think there's no other way, because it must have been the table missing, because all my other tables actually have entries. So if this address were routed to the existing tables, it would have worked. It's not working because the table entry is just missing. As I said, it's level 2. Okay, it's level 2. So our explanation was correct, because even here we managed to confirm that it must have been translation fault level 2. What the fuck? Probably we are running out of memory. But it's L2 table entry. Because if it's L2, that means we ran out of 1 GB. Because in L1, my L1 tables are supposed to take up to 512 GB. L2 tables are supposed to take up to 1 GB, and L3 tables are supposed to take up to, per index within the table, is supposed to take up to 2 MB. So if it is a L2 fault, that means I'm running out of my initial 1 GB. Is that what is happening? Okay, as you can see, we have L1, and in L1 we have the third index, and L2 we have the fourth index. Okay, so it is, we got a valid entry in L0, L2, and in L2 we have the error. Oh, fuck me. Okay, so L0 is my L1. Then it's correct. My L0 table can take up to 512, L1 can take up to 1 GB, and L2 is taking up to 2 MB. So it's correct. I just fucked up the index because I didn't count from L0. So it's fine. So my L2 table is supposed to only have 2 MB, and probably we ran out of all 2 MB data. Is that what happened? Mm, okay, I don't understand anything, but let's push through. But I get the point it is trying to make. It's just saying that somehow we try to access this offset and that offset. But what does the offset has to do with my Kmalloc not being able to allocate that space? Is it that we try to allocate this much memory? Without fixing anything, that does not matter. What the fuck? Okay, now I get it. So the issue is that in where's my file, if we go to our inodes table block and if we search for that, for every block I'm exactly using like as I said, every physical block is only 4966 bytes, at least in my setup. So I allocate that memory and then I read the inode table into it. And I can only index anything in that range. And I'm not supposed to read something like this, which is what 49. So, but then what's the issue? Why is my offset to why? But how come my offset is that big? Shouldn't all index be relative to 4096? Because if it's not relative to that particular block, that means that offset does not even belong to that block. At least that's how I remember it, because relative indexing is that within a group. Okay, it's the group's inode table, and the table is 2 MB, not 4 KB. Okay. Pockets. But how can I be sure? It might be fucking hallucinating. Right, let's just fucking recall that. We need to go to X4 and group table size, group table, group table. It must be here. Wait, it will be every block should have a table. Inode table. That is the one, right? Inode table block. Current groups, inode table. Yeah, current groups, inode table. Standard group looks like this, and we have an inode table. And what's the size of the inode table? Size is okay. The size of the inode table is many blocks, not just one block. Then how do we know what's the maximum size? Okay, that's the information that we missed, because for inode bitmap, it's just one block. So we are not supposed to consider that inode table will be only just 496 bytes. Inodes tables could be more than one block. Okay, if that's the case, then we just have to make sure the relative index is within that, and then we allocate it. So it would be like event 64 relative mults. So we multiply 4096 into, no, we divide relative index divided by 4096. Now we can actually multiply that with this relative multiply. Now we can actually I don't know if my block can actually support that, but let's try. So what I did is that, as you can see, a single group can have multiple blocks. I mean, a single table can be of multiple blocks. In that case, then based on the relative table index, if that is more than 4096, I just have to divide it by 4096. Then I would actually get the number of 4096 blocks I need to allocate, and then I can read that much data. Or actually, I don't even have to allocate that many tables. I can just allocate it one 409 block, and if I divide it, I would get inode table block plus relative mult. If we do this, then we have the current block, and we need to go to this particular block because that particular block has this relative index, and in that index we are supposed to actually use percentage properly. Yeah, if we use percentage in that relative index, then it would again round to 4096. So it would be a relative node index equal to relative node index percentage 4096. Then I would just get the remainder. Reminder would be the actual index, I guess. I don't know, let's try. Maybe it will break our existing setup first of all. Well, let's try. Okay, we have the same fucking issue and the relative index is something really big, which is wrong. We just, where's the relative index? Print message. Okay, here we are printing the exact relative index. Why is it not working? It should have worked. My idea was pretty straightforward because the issue was that we could have multiple blocks, and I was only reading the first block and I was trying to index offset that's somewhere down some other block. So doing instead of allocating the entire table, what I did is just take the index divided by 4096. Now I would get the actual block number, so I can take the index block plus that number, so we would get that particular block, and within that block I'm supposed to index a relative one, so that's why I use percentage. Why it didn't work? It should have fucking worked. Why is this not working? I'm trying to work around the idea of only allocating the block that actually has the offset. It should work. Read only the block that contains the inode, and arithmetic is broken. What? Okay, I guess it's some other issue. We just have to figure out how to properly add that block size I guess I can do that tomorrow, but let's just write this down as a to do. Figure out how to fix this relative indexing. Okay, guys, today we finally at least figured out what was the initial issue. It's just a page faults, and where did that page fault occur? It occurs because we allocated only a specific bytes, and then we are trying to access a really big offset, which is just completely wrong. So the issue is not even with the MMU, it's just simply we are accessing something that's not supposed to be accessed. So we just have to make sure we properly allocate the block and properly index it. Yeah, okay. So let's try that tomorrow. Okay. Thank you guys. I'll see you tomorrow then. Bye.